Hello 108 class, welcome to section 6.4 where good news, we are not going to learn any new techniques here. We are going to fine-tune and improve our factoring skills, and this section is called a general approach to factoring, and we'll go ahead and we'll tackle the page 1 here. We only got 2 pages here, so this is a summary. And what I like about this here, I really like that the book took a time out to pause for a second and ask you guys to kind of figure out some high-level strategy steps. Think of reads, and in class I talk about Kellen Moore, which now he's not the quarterback for Boise State Broncos, but he was a great quarterback, and one of his great strengths was his ability to look at the defense and read the coverage that the cornerbacks and safeties were providing on his wide receivers and figure out what was going to be the fastest way to get the ball down the field to the correct wide receiver. And so try to think of this section as the way to say, here's a factoring, and say, what are you dealing with? Okay. The book has some general strategies here. I summarized them here. This is on page 339 out of your book here. And so always start with rule number 1. I've said it over and over again. Look and see if you can pull out a greatest common factor. You must always get used to looking for that. If you see a GCF, pull it out, then continue to work on factoring. Then ask yourself, if you see that the polynomial, remember, a polynomial is a collection of terms. If it's a binomial, meaning 2 terms, okay, look for the difference of squares or cubes, either one, or the sum of cubes. Okay, now each of those 3 things are binomials, so you look for the sum or difference of cubes and the difference of squares. Okay, so you look for them and then you apply the shortcut rules that we've learned. Okay, if the polynomial is a trinomial, you're going to look to see if you might have a perfect square trinomial. If you do, go ahead and use that shortcut that we've covered already. If not, then you're going to use reverse FOIL or FLOY. Okay, so there's a kind of a logic flow process through this. Step number 4 is, if you happen to look at the polynomial and it's greater than or equal to 4 or more terms, then you're going to use grouping to factor it. Okay, so we've covered all those 4 techniques. It's just a matter of now getting extra practice here, and so let's just go ahead and start here a little bit here. Let's look at objective 1. Look for the GCF. You see a binomial here, but always look for a GCF, and the answer is, I see 8 and 4, so I could pull a 4 out. I see the variable m is in both terms, so I pull it out, and you're going to pull out the smallest exponent, so it's m to the first. I see p squared and p to the first, same thing, so you're going to pull out a p to the first. And then you ask yourself, take the GCF 4mp, multiply by what to get 8m squared p squared, and the answer is 2mp. Okay, same thing, 4mp times itself is 4mp. And there you go, you factored it. You look inside here, you do not have the sum of cubes here, so you're done, you've factored it. Okay, let's take I did it again. Let's take a look at objective 2. Factoring binomials. Okay, so we're looking at objective 2, and here are the 3 shortcuts of factorings. Again, I like the way how I use them here. I like to say, do you have the difference of squares? Match the pattern, and then you guys remember the drill. Drop down the first square root, drop down the sign. I actually start over here. Drop down the first square root, drop the sign, which is a minus, drop the second square root, and then multiply it by its conjugate, x plus y. How about the difference of cubes? Okay, we've done these. I really like when students use this idea of proving to themselves they've got a cube root and they've got the difference of subtraction of cube roots. If you got that, drop the first cube root, drop the sign, drop the second cube root. Take the first cube root and square it, multiply the 2 cube roots, and then take the second cube root and square it. Those words are a whole lot better than x's and y's in my opinion. The sum of cubes, You've learned the rule. The only difference is instead of it starting with this difference, it's an addition, but it's the same thing. Okay, do you have the cube root of the first term? Do you have the cube root of the second term? When the answer is yes, drop it down, drop the sign. So let me just take advantage of this. Here's how I would start this: x plus, because I dropped the sign, plus y, which is again the second cube root, and then you go ahead and multiply it by, take the first cube root, square it, and then take the opposite sign. That's the part you got to remember. Take the opposite sign. So subtraction went to addition. Now you multiply the two cube roots, and then it's always addition on the second one. Take the second cube root and square it. Okay, and that's how those work. Now we've done these problems before, so we could kind of quickly look at these and say, look at this and say, do you have the difference of squares? The answer is yes. Can you put it in the form? You can see that I took the square root of both of these two terms. Then what do I do after that? I drop down the first square root. I drop the sign. I drop the second square root. And I multiplied it by the conjugate. Okay. Example 2b. I look at this, and you're looking for clues. What are you dealing with? A binomial, two terms. You got subtraction. I see that p to the third, and it makes me think of, do I have the cube root of the first term? The answer is yes. 2p raised to the third power is 8p cubed. Do I have the cube root of 27? Yes, it's 3. Okay, so I match the pattern. What do I do? Drop the first cube root, drop the second cube root, drop the sign. Now, take the sign, make it addition. Take the first cube root, square it. Multiply the two cube roots, and finally take the second cube root and square it. Final answer over here, 4p squared plus 6p plus 9 times the quantity 2p minus 3. Okay, there's page 1 of our notes here for section 6.4, so it's a good review. You must. I encourage everybody to work hard on factoring. You're going to factor, and chapter 7 we're going to do it more. So you must feel comfortable that you know how to do it. Okay, so Mr. McHugh, we're going to sign off here on this page 1. Check it off, and I will see you for page 2. Okay, bye-bye.